Okay, now it's time to test your model on one more type of generalization performance. So we're going to do another type of out-of-distribution generalization test in this tutorial, and it's going to be even more difficult than the spatial generalization test. Okay, so you may have noticed that in the description of the climate bench data, we talked about there being 5 SSPs that the Earth system model was run with. But in the data set that we've been working with, there are only 4 SSPs represented, and you had to plot the emissions trajectories for these different SSPs. So the fifth one, SSP 245, is shown with the black dotted lines here in this figure from the climate bench paper, and that one is intentionally held out as a test scenario. It's meant to test how well the model generalizes if it was only trained on certain SSPs. How does it generalize to a new one? So this is a new emissions profile that it hasn't seen. Can it still predict climate variables well? Can your model still predict the temperature given this new SSP as input that it hasn't seen before? Now, this new SSP, as you can see from these plots, the emissions are kind of in between the more extreme other scenarios. So in some ways, this is still kind of a little bit within distribution in the sense that it's not like you're trying to put in a completely radically different type of emissions profile, but it is definitely something that the model hasn't seen. It hasn't seen this exact emissions profile in any of its training. And it's important to test if a climate model emulator can work on a held out scenario like this. The main benefit of these emulators is to be able to quickly explore the outcome of new scenarios, to say, what if we change this? What would happen? What if we were able to reduce our emissions faster? What if it takes longer? All of these different things that you want to be able to explore in terms of what would happen if you want your model to be able to generalize to new scenarios so that you can explore those hypotheticals without having to run the full Earth system model, which is very computationally and time intensive. So the ability of an emulator to perform well on held out scenarios is absolutely crucial for it being useful in the real world and being applied to help people make policy decisions and other decisions about what to expect in terms of how the climate changes in response to different ways that we could choose to act. So now is your chance to see how well your model that was trained on these 4 SSPs performs on this held out SSP.